All right, tonight's homework starts with some long division problems. So it just says divide using long division for the first problem. So I'm going to set this up. Got the divisor, 4x plus 5. The dividend is not missing any terms, so no placeholders to fill in. And we go through and say, what will we multiply 4x by to get 4x to the third? That's x squared. And then you multiply that result through 4x plus 5. Negative 7 minus 5 is negative 12x squared. Drop down the negative 11x. Repeat the process. What do we multiply 4x by to get negative 12x squared? That's minus 3x. Multiply negative 3x by 4x plus 5. Subtract the quantity. X squareds cancel. Negative 11 plus 15 becomes 4x. Drop down the plus 5. What do we multiply 4x by to get 4x? That's positive 1, which gives you 4x plus 5. Subtract the quantity, comes out to 0. So again, the directions were just divide. So our answer, the quotient to the division problem, is what we have on the top. X squared minus 3x plus 1. Same instructions for the next problem. You'll notice they put the terms out of order. I'm also looking at these and seeing there's no x to the third and there's no x. We have to fill in those placeholders. And placeholders, you need to do that whether it's in the dividend or the divisor. But our divisor looks okay. So let's rearrange the terms here. The divisor is x squared minus 2x plus 3. So get that in general form. The dividend is x to the fourth plus 0x to the third plus 3x squared plus 0x plus 1. And then we would multiply x squared by x squared to get x to the fourth. Distribute that through. Subtract the quantity. 0 plus 2 is 2x cubed. 3 minus 3 is 0x squared. Drop down the 0x. And start again. X squared gets multiplied by 2x to get 2x to the third. Distribute that through. You get 2x to the third minus 4x squared plus 6x. X cubes cancel. 0 plus 4 becomes 4x squared. 0 minus 6 minus 6x. Drop down the plus 1. We multiply x squared by 4 plus 4 to get 4x squared. Distribute that through. Subtract the quantity. X squareds cancel. Negative 6 plus 8 becomes 2x. 1 minus 12 becomes minus 11. And because what we're left with is 1 degree lower than our divisor, we know we're finished. This whole thing is a piece of the remainder. And then to write the final answer, your quotient is x squared plus 2x plus 4. And remember to write the remainder as a fraction. So plus 2x minus 11 over what you were dividing by, x squared minus 2x plus 3. So for these division problems, we're not solving anything. We're not saying x equals this. We're just dividing according to what they give us. The next two problems use synthetic division. Remember, we wouldn't have been able to do synthetic division for number 18 because we have a quadratic divisor. So with synthetic division, if you're dividing by x minus 5, you're really looking at the 0, x equals 5. And that's what you set on the outside of your synthetic division. Write the coefficients of the polynomial that we're dividing into, including negative signs. Drop down the first number. Multiply 5 times 3. Add negative 17 plus 15. Multiply. Add. Multiply. Add. We were still just dividing for this, so the answer is, remember this is remainder, constant, x squared. Or another way to think of it, you divided an x to the third by an x, so you're going to get x squared as a result. 3x squared minus 2x plus 5. No remainder, so no need to write a fraction. Same instructions for the next one. The 0 here would be 3/2. We have 3x to the third. We have negative 4x squared. We're missing a 0x, so put in a 0 there. And we're ending with a 5. Also, this is a hard one to see. If we were missing the constant term, if this said plus 5x, no constant, you need to add a 0 for the constant as well. And if you don't, you'll have a number where you'll have a number that you think is a remainder that shouldn't have been, and everything will be bumped up a degree, and it shouldn't have been. So anyway, drop down the 3. 3 times 3/2 is 9/2. Think of this as negative 8 over 2 plus 9 over 2. That's 1 over 2. 3/2 times 1/2 is 3/4. 0 plus 3/4 is 3/4. 9/8. Think of this as 5 is 40 over 8 plus 9 over 8 is 49 over 8. Okay, now writing this one out is kind of weird. So again, this is the remainder. This is the x squared term. So we can say 3x squared plus 1/2 x, or you could say x over 2 plus 3/4. And then normally we put the remainder in the numerator and what we were dividing by in the denominator. But this is kind of ugly. We don't like complex fractions, right? And we've spent some time simplifying complex fractions throughout different homeworks and notes and stuff. So simplify this. Don't leave it like this. You could say instead of 49 over 8, you could say this is 49 over 8 times x minus 3 over 2. So a fraction divided by something else, that 8 can be in the denominator, right? And then if you distribute the 8 through, you also would get rid of that fraction. So that's how I wrote my final answer. 3x squared plus 1/2 x plus 3/4 plus 49 over, if I distribute this, 8x, 8 over 2 is 4 times 3 is minus 12. So that's how I would prefer the final answer. Is it wrong to leave it like this? No, but we do need to simplify things for our AP test. And if we would likely be looking for this in a multiple choice answer. This is not a typical free response question. So it might be that you're looking for the simplified version, I would imagine. Okay, number 45. The directions said to use the remainder theorem to evaluate the function. And it did also say, use the remainder theorem in synthetic division to find each function value. Verify your answer using another method. I'm not going to do that, but the other method would be plug the numbers we're evaluating straight in, 3 to the third, minus 5 times 3 squared, etc. Or graph and find the value at 3. So that's your other option if you wanted to double check your answer. I'm not going to do that on the video. So the remainder theorem says we should be able to take our function value that we're evaluating at, perform synthetic division, and whatever winds up in this remainder spot is equivalent to the function value. So h of 3 is equal to whatever number I get right here. So set up synthetic division, drop down the first number, multiply, add, multiply, add, multiply, add. So according to this, h of 3 is equal to negative 35. I'm not going to verify another way, but if I plug 3 back in here, our old traditional way, before today, if I said find h of 3, you would just kind of plug and chug away. You should get negative 35 as well. Evaluate h of 2. So put 2 on the outside of synthetic division. Drop down, multiply, add, multiply, add, multiply, add. The remainder is the function value, evaluated at 2. Check that on your graphing calculator. Same thing. Now we're evaluating at negative 2. Double check that I got -10 on my key. Yeah, I did. Just checking. I don't have my other key in front of me, so I wanted to make sure I didn't remember that answer. Okay, so h of -2 is -10. And finally, -5. I find that when we have a quiz or a test over this in years past, in pre-calculus classes in the past, um, when when students get this question, evaluate the function using the remainder theorem, I find that students remember that they're supposed to do synthetic division, and then they just give me the answer that, like, instead of just saying h of 3 is -35, they'll tell me h of 3 is x squared minus 2x minus 13 minus 35 over x, like, you'll give the entire quotient. So make sure that you're paying attention and you know whether you're supposed to be just dividing and getting an answer or evaluating a function and getting a numerical answer. Let's see, 43 times 5, 15, -2, 15, plus 4, -2, 11. So h of -5 is -2, 11. Okay, the next two problems kind of take us through the point of having synthetic and long division. So 55 gives us a function and gives us two factors of f of x because we don't have a method to factor something that's 5 terms long like that. So verify the factors. You can do this two ways. You could FOIL these two factors together and then do long division. Might get you there faster. Or verifying the factors, what our textbook is kind of leaning for us to do is perform 2 rounds of synthetic division. Most people like synthetic division better anyway, so if you're going to do 2 rounds of synthetic division, pick either one of the factors and find its 0, set up synthetic. And always kind of be mentally checking, like, am I missing anything as I write these down? Missing any terms, and we're not. It should be that we end up like this, right? If the math has gone correctly. So, because we're being told these are factors. So we should get a 0 remainder. It means we should get -24 there. So let's check this. Drop the 8, multiply, add, multiply, add, multiply, add. Yep, -2 times 12, -24. Okay, good. Now, the second round of synthetic division, this is where people mess up sometimes. The other 0 is 4. You're not going back into the original f of x, because that doesn't help you factor the whole thing. You're going back into what you'd be left with without including the 0 remainder. So this is your constant x, x squared, and x cubed. So you're using just these 4 coefficients in your second round. We're trying to whittle this thing down so we get something quadratic that we can factor. Remember, 4 is supposed to be a 0. X minus 4 is supposed to be a factor. So I should get 0 in the remainder spot, which means I should get -12 right here. And I just have to do the math correctly. Drop down the 8, multiply, add, multiply, add. 4 times -3 would be -12. I get 0. It's awesome. So part A was just verify factors, which I did. Part B was find the remaining factors. So this just means, what were you left with here? You're left with this quadratic, 8x squared plus 2x minus 3. And how does that factor? It factors into 4x and 2x, I would guess. 3 and 1. So if we put 3 here and 1 here, we get 6 and 4. So plus 6 minus 4. So these are the remaining factors. Part C is write the complete factorization. So what does that mean? That means write out f of x completely factored. So they gave us 2 of the factors. Remember to write those. And part B, we found the other 2 factors. Complete factorization just means you should have all of the factors represented so that if you were to go through all the work of multiplying this all back together, you should get back to the original f of x. And then finally, D is list all of the zeros. So f of x equals 0. I don't want to write all those parentheses again. F of x equals 0 when x equals -2, +4, -3/4, +1/2. Part E is like confirm this on a graphing calculator, I think. So again, I'm not going to do that, but yeah, what you would be looking for is when you graph the original f of x, is it crossing the x-axis at these zeros? Are those the x-intercepts? Same thing for 56. This should be shorter because it's only a cubic. So we're given one factor. Verify that factor by using its 0, so -3, coupled with synthetic division. Should get 0 here, which means we should have had -6 there. So let's drop down, multiply, add, multiply, add. The rest checks out. Okay, so verify zeros, done. Find the remaining factors. Remember, this is the remainder, constant, x squared. So we're trying to factor 3x squared minus 7x plus 2. It's got to be 3x and x. 2 and 1 to give me 6 and 1 to make 7. They're both negative. So these are the remaining factors. Write the complete factorization of f of x. So we were given a factor of x plus 3, and we got a result that factored into 3x minus 1 times x minus 2. So here's the same f of x fully factored. If you were to graph this version of f of x in y1 and this version in y2, you'd have an overlapping graph. They're the exact same thing. And finally, list all the zeros. F of x equals 0 when x equals -3, 1/3, and 2. Now, I didn't erase my work for the calculator problems for a couple of reasons. It'll be a shorter video if I just talk through it. I don't have my graphing calculator on my computer right now. I'm trying to get that fixed. So I use Desmos. And so I just want to be able to, that's going to take time to go back and forth through. So let's look at this problem. The numbers of employees, which is E, in thousands, that's important to make note of when you go to label your answers. In education and health services in the US from 2000 through 2017 are approximated by this function. The domain of this function is 0 to 17. T is the year, 0 corresponds to 2000. Okay, so part A was use a graphing utility. Now you're going to have your graphing calculator and not Desmos. Again, mine is broken. So what you should be doing is typing this equation into y equals, using x's instead of t's. Don't let that bother you. And then you should be setting the domain. This is a really common thing for our AP test and for your calculus AP test next year. Set the window they give you, meaning press window, go to xmin, type in 0, xmax, type in 17, and then press zoom, and you should be using option 0, which is zoom fit. Again, zoom fit adjusts the y values so that you'll be able to see the entire graph on this domain. So it will keep the domain that you set, and it will fit the graph. If you just do zoom fit without setting the domain, it won't really show you what you're trying to look at. So anyway, for me, I'm on Desmos. So, and mine's, again, a bit wonky, but we're looking on 0 to 17, right? So like 0 to 17. So this curve here. Yours might look different or more curved or something on your graphing calculator screen. Okay, so part A, graph it. Part 2, part B, estimate the number of employees in education and health services in 2000. Remember, that's when T is 0, so I don't need a calculator for that. If you plug 0 in for all of these terms, you're going to be left with the constant term, which is 15,227. But remember, E is measured in thousands. And because it sounds weird to say 15,227,000, just write that out in numbers. That just means multiply your number by 1,000, put 3 zeros on the end. That's how many employees. We actually had 15,227,000 employees. in education and health services in 2000. Now, this is kind of strange. It says use the remainder theorem to estimate the number in 2015. If we already have a graphing calculator and we already have the window that we're looking at, you could just do second trace, and then you could choose value and type in x equals 15. It's going to be a lot better. But I followed the rules. It says use the remainder theorem. Again, I don't believe our AP test would force us to do such a thing. But anyway, I set up synthetic division. I still used a calculator because I'm not trying to do all of this without. And I got this answer here. So remember, the remainder theorem says E of 15 is equal to that number. Again, that's thousands of people, so I multiplied it by 1,000. I moved the decimal place 3 spots to the right. So in 2015, our model says 22,092,125 employees. Now, Part C is open to interpretation, and this kind of goes to any of you taking stats this year or next year. Is this model good for making predictions in future years? That's something called extrapolation. Extrapolation is not always inaccurate, but I don't know anything about this model outside of other years, and I also don't know about its correlation for the current years. So all I can say is this model was built for 2000 to 2017. We don't know if it's reliable for predictions in the future. So I said may not be. It could be great for future years, but it might not be, and we don't know. Okay, our next one's a geometry problem. This kind of reminds me of ACT and stuff they kind of might want to put on our pre-calc AP exam. So this one takes a little extra thinking. It says a rectangular package was sent by a delivery service that can have a maximum combined length and girth, which is the perimeter across a cross section. What's a cross section? One of these little squares. Like if you slice through this thing, the little shape you would get is a square on the end. Cross section is the square. And that's a combined length and perimeter of 120. So what this is saying is combined our length, y, plus the perimeter of the square, which is going to be 4x, that has to stay less than or equal to 120. So I just kind of put a pin in that. Part A says write a function v that represents the volume of the package. Volume of a rectangular prism, you should know, is length times width times height. Our length is y. The width and height are both x, so x squared times y. And we don't want to have a function. It says write a function. That means you can't have two variables. So we want to replace y with an expression in terms of x, and that's where this little thing comes through. If I solve this for y, it's an inequality, but I'm just going to toss it in, 120 minus 4x. And it's a good idea to get in the habit, not usually required for our AP exam, but good idea to get in the habit of writing domains. So what are the restrictions for this? Well, we can't have a dimension of 0, so x needs to be bigger than 0. And then we can't have this length dimension equal 0 either. So I set 120 minus 4x equal to 0, solved for x. X needs to stay smaller than 30 so that it still fits within the constraints and doesn't give us a 0 or a negative volume. Part B is use a graphing utility to graph the function and approximate the dimensions of the package that gives a max volume. If you do this on your graphing calculator, you should be setting x min to 0, x max to 30, and then zoom fit. For me, I use Desmos. So let me try to show you this. So here's the function in Desmos. We're on 0 to 30, so that's pretty good there. And Desmos, it's a little harder for me to guarantee that this is the max because I don't know how to easily drag that around. But it looks to me on this interval that this is the highest point. When x is 20, and remember this is the volume. Volume is 16,000. So that's where these numbers came from. Find the dimensions. That means what is this length, what is this width, what is this length here. So if x is 20, that means y is 120 minus 4 times 20, 40. So the dimensions are x by y. So I said 20 inches by 20 inches by 40 inches. And finally, find the values such that the volume is 13,500. Now this one I kind of half did again because I just was running out of time on my homework assignments, but I can, on my graphing calculator, put into y2, 13,500. And if I do it this way, if I don't solve algebraically, and I'm on my 0 to 30 domain, I'm not going to get any extra answers. It said, which of these values is a physical impossibility? So these two answers that I get from my graphing calculator or from Desmos, 15 and 24.27271, those are both perfectly fine because they're within the domain. This 24.271 came from quadratic formula. So if we were to do this the long way, we would say 13,500 equals our x squared times 120 minus 4x. We would get this equal to 0 and like go out. And then we could find the zeros by factoring or by quadratic formula. And so the quadratic formula, after we divide out our 15, the quadratic formula gives you one answer, which is the conjugate of this one. Quadratic formula is like something plus or minus square root of blah, blah, blah. That answer gives you a volume that's negative, or another way to think of it is it's outside of the 0 to 30 domain. So that one kind of went above and beyond. For our AP test, we would simply just be on our calculator, finding these 2 points with decimals. If you're using a calculator on our AP exam, you do not have to find exact answers. You're rounding to 3 places. Okay, final question. This is a great question that is very AP-like, so something that you'll see this year and next. Find the value of k such that x minus 3 is a factor. So what does it mean to be a factor? It means that if we do synthetic division with 3, which is the 0 coming from this supposed factor, we should get a 0 remainder in the end. So let's set up synthetic division coefficients. Now k is this constant number, so it is a coefficient, negative k, 2k, and negative 12. So it should be that, let me fix where I put my 0. I should get a remainder of 0, which means I should get 12 right here. So let's see what happens when we start doing this. Drop down the 1, multiply. Now these are not like terms, so when we say add negative k to 3, I'm just going to write 3 minus k. And then multiply 3 times 3 minus k, you have to distribute 9 minus 3k. Add 2k to that, you get 9 minus k. You're adding like terms. Multiply, so I know I already wrote a 12 in here. I'm just going to write above this. 27 minus 3k is supposed to be 12, so that this adds up to 0. So I'm going to say this. If x minus 3 is a factor, then 27 minus 3k equals 12. Let's solve this for k. So I'm going to add 3k over here, subtract 12 to this side, divide by 3. K has to equal 5. So that is definitely, I think, a candidate for an AP type question, something like that. That's a pretty good one. All right, come to class tomorrow with any questions you had. If there was anything confusing on the video, we can go over it, or come to office hours. I should be there tomorrow.